Hello students, welcome to this lecture, one real numbers. So in this lecture, we'll discuss previous year questions, one real numbers that came one board exam. Okay, so let's get started. Okay, question number 1. Here we have asked, what is the greatest possible speed at which a girl can walk 95 meter and 171 meter in an exact number of minutes? So this question basically is a previous year questions of CBSE board exam. Okay, so here basically we have to find the greatest possible speed at which a girl can walk 95 meter and 171 meter. Okay, so for solving this question, here basically you will use HCF. You know what is HCF? Highest common factors of two numbers. Okay, so for finding HCF, we can use prime factorization method or Euclid division algorithm. Okay, so 95, this is basically equal to 5 into 19. So the prime factorization of 95 is 5 into 19, and the prime factorization of 171, this is equal to 9 into 19. Okay, so here you can observe that the common factors in two numbers is basically 19. Okay, and the lowest power of the common factors in both numbers is actually HCF of both, HCF between two numbers. So here 95, this is equal to 5 into 19, and 171, this is equal to 9 into 19. Okay, so HCF of 95 from 171, this is equal to 19. So this method is basically best one prime factorization method. Okay, so now we can use Euclid division algorithm also for solving this problem. Euclid division algorithm. You know what is Euclid division algorithm? So if A is divisible by A, if B divides A, where A and B are integers, okay, so B divides A, then we can write A, this is equal to B times quotient plus remainder, where remainder is between 0 and B. 0 less than equal to R, less than strictly less than B. Okay, so this algorithm is called Euclid division algorithm. So if we use this algorithm, then we can write 171, this is equal to 1 into 95 plus the remainder is what? 171 minus 95, this is equal to 76. Okay, so plus 76, and 95 can be written as 76 times 1 plus the remainder. Remainder is what? 95 minus 76, that is 9 here, 1 here, so 19, and then 76 can be written as 19 into 4, okay, plus 0, the remainder is 0. So here HCF of 95 comma 171, this is equal to 19. Okay, so by using Euclid division algorithm, we get HCF of 95 comma 171, this is equal to also 19. Okay, so here this is prime factorization method. So by using prime factorization, you can find the HCF of 95 and 171, that is equal to 19, and you can also use Euclid division algorithm. Then you can also find the HCF of 95 and 171, this is equal to also 19. Okay, so here for this question, answer is option number B. Option number B, is correct option for this question. So the highest, the greatest possible speed at which a girl can walk 95 meter and 171 meter in an exact number of minutes is 19 minutes. Okay, so here option B is correct option. Now let us move to next question. So in next question, here we have asked 3 alarm clocks ring their alarms at regular intervals of 20 minutes, 25 minutes and 30 minutes respectively. Okay, together at 12 noon, at what time will they beep again for the first time? Okay, so we have 3 alarm clocks. Okay, and their ring their alarms at regular intervals of 20 minutes, 25 minutes and 30 minutes. And at 12 noon, they first beep together. Okay, and here we have asked at what time will they beep again for the first time. Okay, here we have given 4 options. First options we have 4 p.m., 4:30 p.m., 5 p.m., 5:30 p.m. Okay, so for finding the time, at what time will they beep again for the first time, here we'll use the concept of LCM. Okay, so here we have given this regular intervals 20 minutes, 25 minutes and 30 minutes. So basically here we have to find LCM of 20, 25 and 30. Okay, so LCM of 20, 25 and 30. You can find the LCM of 20. So you can first factorize. Here we use factorization method. So 20 can be factorized as 2 square into 5. And 25 can be factorized as 5 square. And 30 can be factorized as 2 into 3 into 5. Okay. So here the prime factors are 2, 5 and 3, and the LCM is basically the highest product of highest power of prime factors in numbers. So here the highest, the prime factors, the highest factor is power is 2. So here we take 2 square, and for this prime factor 5, the highest power is 2. So we take 5 square, and for the prime factor 3, the highest power is 1. We take 3. So if we product then 2 square into 5 square into 3, then we'll get the LCM of these 3 numbers. Okay, so this is equal to actually 4 into 25 into 3, and this is equal to 300. So these are all in minutes, so here we'll get 300 minutes. Okay, and 300 minutes, this is basically equal to 5 hours. So for this question, here option C will be correct. So at 5 p.m. they will beep again for the first time. Okay, so here option C is correct option. Now let us move to next question. So in next question we have asked the greatest number which when divides 1251, 9377 and 15628 leaves remainder 1, 2 and 3 respectively is what? Okay, so here we have given 4 options. So among these 4 options, which option will correct, that we'll have to say here. Okay, so basically we have to find here the greatest number which when divides this number and this number and leaves remainder 1, 2 and 3. Okay, so basically here for solving this question we have to use the concept of highest common factor. Okay, so greatest number is basically highest common factor of these 3 numbers. 1251 minus 1, 9377 minus 2, and 15628 minus 3. Okay, so basically for finding greatest number, we need to find HCF of these three numbers 1250, 9375 and 15625. Okay, so we can find HCF of these three numbers by using prime factorization method or Euclid division algorithm. Okay, so HCF of these three number is basically is equal to 6 to 5. Okay, so HCF of these three numbers is equal to 6 to 5. So here, in which option we have given 6 to 5? So here you can see in option D we have given 6 to 5. Okay, so the greatest number which when divides this 1251, 9377 and 15628 and leaves remainder 1, 2 and 3 respectively is 6 to 5. Okay, so here option D is correct option for this question. So here for this question, option D is correct option. Okay, students. So I hope you got it. Basically, when we have to find greatest number of three numbers or two numbers, that case we have to physically find the HCF of that numbers. Okay, so this trick must be kept in mind when we need to find the greatest number. That case we have to use the HCF or highest common factor concept. Okay, so now let us move to next question. So in next question we have asked if A and B are two co-prime numbers. A and B are two co-prime numbers, and you already know what are actually co-prime numbers. So what are co-prime numbers? Two numbers A and B are called co-prime number when HCF of A and B is equal to 1. That means A and B have no other common factors other than 1. Okay, so that case we say A and B are two co-prime numbers. In one words, when GCD or HCF of two numbers is equal to 1, then that two numbers are called co-prime numbers. So in this question, we have given A and B are two co-prime numbers. Okay, and then we have asked what about A cube and B cube. So if A and B are two co-prime numbers, then A cube and B cube are which type of numbers? Okay, so in option A we have given co-prime, in option B we have given not co-prime, in option C we have given even number, and in option D we have given odd number. Okay, so let us solve. So A cube and B cube will be also co-prime numbers if A and B are co-prime number. Okay, so you can take example. So you can take this example, A is equal to 6 and B is equal to 7. Okay, so here you can check 6 and HCF of 6 and 7, this is equal to basically 1. HCF of, sorry, if we take more small number, here we take A is 3 and B is 3. A is 2 and B is equal to 3. So now here you can check 2 and 3 are co-prime, okay, since the GCD of or HCF of 2 and 3 is equal to 1. Okay, so 2 and 3 are co-prime number. Now A cube, this is equal to 2 cube and this is equal to 8. Okay, and B cube, this is equal to 3 cube and this is equal to 27. Okay, and now if we find HCF of 8 and 27, HCF of 8 and 27, this is basically equal to 1. Okay, so 8 and 27 are also co-prime numbers. So if A and B are co-prime numbers, then their cube, that is A cube and B cube, will be co-prime number. Okay, so here you can see in option A we have given this option. Okay, so co-prime. So here option A is correct option. Here option A is correct option. Now let us move to next question. So in next question we have asked, if n is a natural number, then 2 times 5 to the power n plus 6 to the power n always ends with which number? Okay, so here given basically n is a natural number, and here we have asked at which numbers this number will end. Okay, so here you can see 5 to the power n, this number will end with 5, and 6 to the power n, this number will end with 6. Then 5 to the power n plus 6 to the power n, this number will end with 11. Okay, and then 2 times 5 to the power n plus 6 to the power n will end with 22. So here basically 2 times 5 to the power n plus 6 to the power n will end with 1. Okay, so here you can see the solution. So unit digit of 5 to the power n and 6 to the power n are 5 and 6 respectively. That means 5 to the power n and 6 to the power n will end with 5 and 6 respectively. Okay, where n is a natural number, and therefore unit digits of 2 times 5 to the power n plus 6 to the power n, this is basically equal to 2 times 5 plus 6, and this is equal to 2 times 11, that is equal to 22, that is 2. Okay, this is equal to 2. Okay, so here this number 2 times 5 to the power n plus 6 to the power n will always end with 2. So it will not end with 1, not b4, not at 3. Okay, so basically if n is a natural number, then 2 times 5 to the power n plus 6 to the power n always ends with 2. Here option D is correct option. Okay, now let us move to next question. So in next question, here we have given LCM of two numbers is 200, 2400. Okay, and here which of the following cannot be their HCF? So we know this result. LCM of two numbers a comma b times HCF of two numbers a comma b. This is equal to product of numbers a into b. Okay, so here the LCM of two numbers is this, then which of the following cannot be their HCF? So here from this we can find LCM of a comma b, this is equal to a cross b divided by HCF of a comma b. Okay, so LCM is given 200, 2400, and among these four options, which options will be correct, that we will have to say here. Okay, so here we can observe in option A 300, this divides 2400. Okay, so the HCF of these two numbers may be 300. Okay, so according to this question, options A is basically wrong, and here you can observe that 400 this also divides 2400. Okay, so the HCF of two numbers may be 400. Okay, maybe 400, so this option is also false. And in option C we have 500. So here you can see 500 does not divide 2400. Okay, but HCF of two numbers must be divides LCM of two numbers. Okay, according this result. So 500 is here does not divide 500 does not divide 2400. So HCF of two numbers cannot be 500. Okay, so according to question here, option C is correct option. And if we see option D, so in option D here this number 600 divides 2400. Okay, so HCF of two numbers may be 600. This option is also false. So here only correct option is option number C. The correct answer is option number C. Okay, so here basically we use this concept 2400 is not divisible by, for being HCF of two numbers, HCF of two numbers must be divided LCM of two numbers. But here 2400 is not divisible by 500. So the answer C, option C is correct option. Okay. So now let us move to next one. So in next question here we have given two numbers 30 and 70, and we need to find the product of HCF into LCM. Okay. So student, you know this result, HCF into LCM. This is equal to basically the product of two numbers. Okay. So for two numbers, this is true. Okay. So HCF of A comma B times LCM of A comma B, this is equal to product of A and B. But if you take three numbers, then that case HCF of ABC times LCM of ABC does not equal to product of ABC. Okay. So this must be kept on your mind. For three numbers, this result is not hold. But if you have two numbers, okay, and then that case HCF of two numbers into LCM of two numbers, this is equal to product of these two numbers. Okay. So here if we use this result, so we know HCF into LCM, this is equal to product of two numbers. So HCF into LCM is equal to 30 into 70. That is given in our question. Two numbers 30 and 70. So HCF into LCM, this is equal to 30 into 70, and this is equal to 2100. Okay, this is equal to 2100. So here basically we use this result, HCF of A comma B times HCF of LCM of A comma B, this is equal to A into B. Okay, so use this result. So if you use this result, then we will get HCF of 30 comma 70 into LCM of 30 comma 70. This is equal to 30 into 70, and this is equal to 2100. Okay, and now if we see the option, so here in option A we have given 2100. So here the correct answer is option number A. Okay, so option number A is correct option. Okay, students. So I stop here this lecture. Thank you very much to all of you.